All right, guys, this lesson is on rectangles. So this is the next quadrilateral that we're going to kind of dissect today. So 2 pages notes, goes kind of quick. Here we go. This is rectangles have the same properties of parallelograms, which we talked about last week. So kind of review these quick bullets, and we'll add 2 more to the rectangles. Just remember, opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, which means they add up to 180. And the diagonals bisect each other, which means they cut each other in half. 2 more for rectangles. All 4 angles are right. So if you look at a rectangle, all the angles in the corners are all right, 90 degrees. And the second one, your diagonals are congruent. So your diagonals are the exact same length in rectangles. All right, some examples here. Says each quad is a rectangle. Find the missing measures. All right, so here we go. Top and bottom congruent. Top's 24, bottom's 24. Left's 10, right's 10. Then we kind of go to work. All right, first one says, what is the distance of QR? Well, we got that one, that's 10. SR, got that, 24. Now it wants SQ. It wants this whole piece right here. So what we can do, we're going to use a Pythagorean theorem. I'm going to highlight a triangle for you. So if you look at that triangle right there, right? I know my 90's right here. A squared plus B squared equals C squared. So 24 squared plus 10 squared equals X squared, which should be this piece right here. Add up that left side, that comes out to be 676. Then we square root both sides, get rid of the square, and that comes out to be 26. So this whole diagonal right here is 26. Which means if I cut it in half, this piece would be 13, that piece would be 13. Diagonals are congruent, so all of those are 13. How long is PR? 26. How long is QT? 13. Number 2, top's 27, bottom's 27. Every piece in here is 15. First piece it wants is AC. How long is AC? 30. BD? 30. BE? 15. AB? 27. BC, this piece over here, we'll call it X, right? So once again, we got to use Pythagorean theorem. Highlight the triangle for you. My 90's right here. A squared plus B squared equals C squared. So X squared plus 27 squared equals 30 squared. Subtract over the 27 squared. So in the calc, you would type in 30 squared minus 27 squared. If you do that, you should get 171. Then we square root that, 13.1. So BC, 13.1. Number 3, the angles. Remember, these are all 90's in the corners, right? So if I take 90 minus the 27, that comes out to be 63. Also, we need to remember this, guys. All these diagonals inside are congruent, right? So if I look at this top triangle right here, it's an isosceles triangle. If I have congruent sides, that means I have congruent bases. So if this guy is 27, this one is also 27. And this triangle is the same as this one right here. So these angles down here are also 27. The sides, these are also the same triangles, and they're isosceles. Congruent sides, congruent bases. 63, 63, 63. And the last one, these middle pieces right here. Remember, all angles in a triangle have to add up to 180, right? So if I take the two 27s and I add them up, 27 plus 27 gives me 54. I subtract that from 180. This angle right here in the middle will be 126. These are vertical, so this guy is also 126. And then last one, angles on a straight line have to add up to 180, right? So if I want to find this one right here, I just take 180 minus that 126. And that comes out to be 54. 54. 54. Remember, vertical angles congruent. And that basically, you can fill this in if you want to, guys, but we have all the angles filled in right now. 4, same thing. Let's do the vertical angles first. That guy would be 64. Angles on a straight line have to add up to 180. So 180 minus the 64, that comes out to be 116. All right, remember all these diagonals are congruent, right? So if let's say I want to find these two angles right here, right? I know both of those are congruent because it's an isosceles triangle. So I would take 180 minus the 64, then divide by 2 to get those angles right there. So 180 minus the 64, divide by 2. Comes out to be 58. So this guy's 58. That guy's 58. 58's down here. You remember the corners add up to 90, right? So if I take 90 minus the 58, I'll get this one right here. 90 minus 58, 32. 32, 32, 32, 32, and there's all of your angles. Number 5, got to fill some stuff in. D to B is 42. So remember, these are all congruent. So if this whole thing is 42, and I cut that in half, each of these pieces have to be 21. 21, 21, 21, 21. A to D, 26, which means that side's 26. And I'm going to do another one for the angle so it doesn't get too confusing. A, B, C, D. And then it says angle DAE right here is 52. And that's all it gives us. All right, so let's do the sides first. First question wants AC. How long is AC? That's the diagonal right here. The whole thing would be 42. E to B, right there, 21. B to C, 26. A to B. All right, let's do a triangle, Pythagorean theorem. So they want to figure out, all right, how long is it from A to B? We'll call it X. A squared plus B squared equals C squared. So X squared plus 26 squared equals 42 squared. Subtract over the 26 squared. That comes to be 1,088. Square root that. And it comes out to be 33. So A to B, 33. Okay, the angles. First one is ADC. ADC, this whole thing, well, that's a 90, it's a corner. ABD. ABD right here. Well, this whole corner is 52. 52 90 minus the 52 comes out to be 38. So ABD, 38. BCA, this guy right here, we'll check it out. Remember, these are all congruent to the middle. So if this guy is 52, this guy is also 52. DEC, DEC, it wants this guy right here. All right, we can do this. Remember, these are all 38. We have 180 degrees inside of a triangle. Add these two up, subtract from 180, and we have this one right here. If you do that correctly, it comes out to be 104. Next page. Some algebra. Find EF. All right, we know top is congruent to bottom, set them equal, solve for x. 3x plus 5 is 7x minus 39. Subtract over the 3x. Add 39 over. Divide by 4. X comes out to be 11. Plugging it back in, that comes out to be 38. Let's see. RT is this whole diagonal right here. US is this whole diagonal right there. Find VT. Well, I know that this diagonal is congruent to this diagonal, so I can set this stuff equal to that stuff. So 5x minus 14 is 2x plus 10. Subtract 2x over, add the 14, divide by 3, x is 8, and it wants VT. All right, so here's what I can do. I can plug this back into RT, right, and get the whole thing, and then I can just cut it in half to get this little piece right here. So if I plug it into the whole thing, RT comes out to be 26, but then I cut that in half for VT, and that's 13. Okay, so I plugged it back in here, got the whole thing to be 26, cut it in half to get this piece, 13. Number 8, it's talking about JM, that piece, and MK, that piece. Well, we know all these pieces are congruent, so set them equal. Set that equal to that. X plus 17 is 5x minus 23. Subtract the x over. Add 23 over. Divide by 4, and we get 10. It wants you to find JL. Okay, so here's what I have to do. I'm going to plug it back into JM, which would be this piece right here. Then I got to double that to get the entire piece here. So when I plug it back into this piece right here, that comes out to be, JM comes out to be 27. But I got to double that to get JL. 27 times 2, 54. Number 9, VW is that piece. SU is this whole thing, right? So we got two options here. I got to take SU, and I have to multiply this guy by 2, then I can set it equal, right? Because if I double this piece right here, then I can set it equal to this piece right here because they're congruent. But I got to double this piece right here, then set it equal to this piece right here. So I times that guy by 2. 2 times 9x minus 11 comes out to be 18x minus 22, then equal it to the SU, 16x minus 12. Subtract 16x over, add 22 over, divide by 2, x is 5. Find WT. Well, WT is the same thing as VW, right? This piece is congruent to that piece, so just plug it back into VW. 9 times 5 minus 11 comes out to be 34. Number 10, these angles are congruent. They're alternate interiors, so set them equal to each other. 7x plus 5 is 11x minus 3. Subtract 7x over. Add 3 over. Divide by 4. X is 2. But it wants angle BCE. BCE. It wants this guy right here. Well, if I plug it back in there first, that's going to give me 19 degrees. But then the whole corner adds up to 90, right? The whole thing is a 90-degree angle. So take 90 minus the 19, and that'll give you the angle, which comes out to be 71 degrees. Number 11, I know this corner adds up to 90. I'm going to take this plus this and set it equal to 90. So combine like terms. 3x, 12x, 15x. 2 and negative 17 is negative 15 equals 90. Add the 15 over. Divide by 15 gives me 7. Find angle JHI. JHI is right here. And I know that's the same angle as this guy right here. They're alternate interiors, right? Just plug it in right there. 3 times 7 plus 2, 23 degrees. Number 12. These guys are not congruent, but I know this angle is the same as this one. Those are alternate interiors. So basically, this is x plus 20 as well. I know that these add up to 90 degrees, just like number 11. That guy plus that guy equals 90. X, 5x, 6x. 20 and negative 8 is 12 equals 90. Subtract 12 over, divide by 6, comes out to be 13. Find angle XZW. XZW is right here. That's the same as this one, right? This angle is the same as that one, so take your 13, just plug it in right there. If you do that correctly, this angle comes out to be 57 degrees. 13, solve for x, no problem. I know this angle is congruent to that angle, same thing. And I gotta find that guy right there. Remember, angles on a straight line add to 180, right? So if I take 180 minus that 134, this comes out to be 46. All three angles in a triangle add up to be 180. Combine all of your like terms from these three angles and equal it to 180. 5x, 5x, 10x. I got a 7, and a 46. That comes out to be 60. Equals 180. Subtract 60 over, divide by 10. That comes out to be 12. That is it for rectangles. Do your homework.